Okay, I'm just saying, if you missed this question, I'm reading it. The water levels measured each day during the 2-week period. The graph modeled linear relationship between the water levels in feet and the number of days the water is measured. So it stops here on day 14, and it started here at day 0. It had a water level of 16 feet. Now remember, this is our y-intercept, initial starting point. So the water level increased by 0.25 per day, maybe. Maximum water was 19 feet, maybe. Initial water level was 16 feet. This is a definite true. Because it says which best describes the y-intercept. So while the water level increased by that function, don't get confused, that may be the rate of change, and we have a maximum value of 19.5 feet. But we're looking for what the relationship is with the y-intercept and what that means in the initial, and that's the initial water value, which was 16 feet, and the water level was measured for 14 days. That's true. The water level was measured for 14 days. But we're asking in terms of the y-intercept, so our answer choice is H. A paper airplane was thrown from the top of the building, blah, blah, blah. We're given the function. How many seconds did it take the paper plane to reach the ground? That is when y is equal to 0. Ground is x. Ground is going to be crossing the x-axis. Okay, so we have 60. So that's here. And really, I don't even need to graph it. And they're not going to count off for to graph it. So I'm just going to put 0 is equal to negative 1.5x plus 60. And I'm going to solve for x. So I'm minus 60. Minus 60 is going to give me negative 60. It's equal to negative 1.5x. Divide by negative 1.5. Now note, we're doing the same relationship that we did when we were finding the zeros of the graph with quadratics. The difference being we don't have a quadratic. X is equal to 40. So the answer here, it'll reach the ground when x is equal to 40. I will start on this question.